For this section, we're going to do a little reminder when we're writing for parallel and perpendicular lines, finding those equations. The key thing about the slopes, we know that parallel lines have the same slope. Their slopes are equal, whereas our perpendicular lines have the opposite reciprocal. So we look at the original slope. If it's positive, we do the opposite sign. We make it negative. And then we flip the fraction. For example, if we wanted to find the slope of a line parallel to this green equation, y equals 3/7 x minus 2, the parallel line would have the same slope. And we see in that line that the slope is 3/7. So we know that a line parallel to it will have the same slope of 3/7. But for a line perpendicular to that, we know that we want to take the opposite sign. So we look at the original slope and it's positive. So we know that a perpendicular line is going to have a negative value, and then we flip the fraction and we get -7/3. Something that's useful for shorthand, and then when you take geometry, you'll see symbols. This means parallel. And the symbol that looks like an upside down capital T means perpendicular. So let's try and look at a couple of different problems to see what these questions will look like. Let's say we're asked to find the slope of a line parallel to this given equation. We know parallel means their slopes are the same. So we know it has to have a slope of 3/4. How about this problem? We're asked to find the slope of a line perpendicular to that given line. And you'll notice that this is in standard form. So what we want to do is rewrite it so that it's in slope-intercept form, so we can identify what the slope is immediately. Keeping in mind, slope-intercept form is y equals mx plus b. So what we want to do is we want to get y by itself. Here we go, subtracting the 4x. Leaving us with this equation. We want to get y alone, so the last step is dividing everything by 5. And when we do, we end up with this equation. So now we're still asked to find the slope of the line perpendicular to that. So first, we're going to identify what the original slope is. It's -4/5. For a line perpendicular, we're going to do the opposite flip. So I'm going to look at the original sign. It's negative, so this one's going to be positive. Next, I'm going to flip it. So flipping 4/5 leaves us with 5/4. In this section, we're going to be asked to find equations of lines that are parallel to certain lines and go through certain points. So let's look at this one. We want to find the equation of the line that goes through the point 3, -4, and is parallel to y equals 4/3 x minus 1. What we're going to use the original line for is its slope. This immediately tells us that we have a slope of 4/3. Next, we're going to use the fact that it has to go through that point. So this is where our point-slope equation comes in handy. We have the point and we have our slope. So we're going to write this in point-slope form. And we're done. Looking at this next example, we want the equation of a line perpendicular to this line, 3x minus 11 equals y, going through this point -2, 4. And they specify that they want this in standard form. All right, a lot of stuff to process. But first is, if it's perpendicular, we need to focus on the slope. And that line has a slope of 3. It's helpful if we write it as a fraction, especially because we're talking about perpendicular. So that tells us we're going to take the opposite sign and we're going to flip that slope. So this is positive, so our perpendicular slope is going to be negative. And then we flip it. So the slope of a line perpendicular to it would be negative 1/3. So now, folks, here's the information that we know about this line. It has a slope of negative 1/3, and it has to cross the point negative 2, 4. I have a point and a slope. Yup. I'm going right back to my point slope form just to come up with the equation. So I'm hoping you realize that I plugged in negative 2, 4 into my x1, y1, and I'm plugging in negative 1/3 into my slope. Now I just have to transform this into my standard form equation. Remembering that that form is ax plus by equals c, where my a is a whole number and b and c are integers. Here we go. So we'll distribute the negative 1/3 so we can separate this multiplication. And you'll notice that we have this. So now, standard form means I want my x and y on one side and I want the constants on the other side. So let's do some shifting. We're going to add 1/3 x to both sides, and that gives us this. So now we're just going to move that 4 over to the other side by addition. So that takes us here. And the last thing we need to do is clear the fraction. We want these to be whole numbers, and then that'll make the combination of this a lot easier. So you'll notice I have 3's in both denominators. So the only way I can eliminate that is to multiply the entire equation by 3. Remember, that's the same as 3 over 1. So we're going to distribute that 3 to every term in this equation. 3 times 1/3 x gives us just x. 3 times y leaves us with 3y. The 3 and the 3 here cancel each other out, and that leaves us with negative 2. And lastly, 3 times 4 gives us 12, positive 12. So, folks, last thing is to combine these two like terms. That leaves us with x plus 3y equals 10. So let's end with this example. We want the slope-intercept form of a line parallel to this line and going through that point 2, 3. We know parallel lines have the same slope. So we know the slope of the line we're looking for is negative 6. And that takes us to this useful piece of information. We know the slope is negative 6, and it goes through the point 2, 3. Here comes point slope. And our point slope equation looks like that. So now we just need to transform that into slope-intercept form, remembering that that's y equals mx plus b. So we're going to distribute the 6, the negative 6, to get our y by itself and to combine the like terms. So when we distribute here, we would get negative 6x plus 12. And since this asks for slope-intercept form, we're next going to move the 3 over to the other side. So we add 3 to both sides, which gives us y equals negative 6x plus 15, which is our slope-intercept form.